Hello, and welcome to our monthly lecture. As a reminder, this lecture is being recorded and will be available on our YouTube channel in the following days. My name is Jennifer Levitt, and I'm pleased to introduce our speaker today, Carla Gonzalez. She'll be showing you all the new tools and functionalities in Geoscience Analyst 4.0. If you have any questions during the presentation, feel free to type them into the Q&A or raise your hand. And for those of you on LinkedIn, type them into the comment section. All questions will be answered, but please be aware that Carla might wait until the end to answer the question. Carla, take it away.
All right, thank you, Jennifer. So I'll just head straight here to my blank Geoscience Analyst workspace. And I'm going to get started with that first bullet point, which is to import some ASCII drill holes. And to do that, I will go to File, Import, ASCII in drill holes. And here I'll have the option to update an existing drill hole group, but I don't yet have any drill holes here. So I'm going to skip right over to the geometry import, where I can select my color file, then my survey file. And then now I also have the option to specify whether the positive dip points down or up. So in this case, if the box is unchecked, that means that a dip of -90 will indicate a vertical drill hole going down. But if you have a different sign convention, you can check this box to specify it. Then for the drill hole data, I'll specify my interval log file, which is my assays, and my point log file, which is my geophysics. And once I'm all ready, I can click OK. And it's going to be popping up different windows for us to specify the columns for each file. So here I have my color file, and what I really need are these 5 columns. So the drill hole ID, X, Y, and Z, and the total length. These are absolutely necessary to import your drill holes. And then what we do here is that from this drop-down menu, you can choose the right column header in your CSV file that matches that field. And here at the bottom, you can see our data preview. So we've got kind of a kind of representation of what our Excel file looked like. You'll see I have hole ID, X, Y, Z, and length. So just picking out those correct columns. Now we also have the option to specify an azimuth and a dip. That's in case you do not have a survey file, you can use this azimuth and dip to draw like a straight path at that orientation. And then you also have your status. So whether your drill hole is planned, ongoing, or completed, for example. And just I'll show this on another workspace that you can specify in your preferences. What are your keywords for this? So maybe you don't call yours completed, maybe you call them done or finished or whatever your keyword might be. You can specify them here in the preferences so that when you import, it'll be categorized appropriately. Great, then here I just have the reference that has a type for each of these columns. So whether it's text or float, your preview. So that's great. Let's click OK. We'll do the same for a deviation survey. So here it's survey.csv. We need our hole ID, distance, azimuth, and dip. Types, preview. Awesome. Same thing for our assays. We need a hole ID, a from, and a to. We have all our assays here as well. We'll click OK. And the geophysics, we have hole ID, distance, everything here. We'll click OK. Whoop, and I'm over here. So now we can also take a look at the console panel. You'll see here that now there's more errors and warnings that are very useful to keep track of when you're importing. For example, it told us that there's no color found for these drill holes, so they will not be imported. And then that for drill hole 4Q17, there's no azimuth and dip in the color file, and there's also no survey information. So the drill hole is still being imported, but it's being assumed to be vertical. So always good to keep a track keep your eyes on this. Really good QA/QC when you import before you get going on with your work. Okay, and now looking at these drill holes here in the objects panel, what we have is our drill hole group. And now what we have are tables for each of our files. So for example, if I check my assays table, now it's only showing me the assay logs that were in that file. Same way, if I select my geophysics table, now it's showing me all my geophysics logs. If I click on the azimuth and dip table, it's showing me the azimuth and dip of those drill holes. And then the static survey table is the azimuth, dip, and the depth. So it's very similar to this other one, but the static survey table is a fixed copy of that deviation survey file. So that once you import it, this is not linked with the drill hole path, so that if you modify that drill hole path, this is going to stay the same. So it's a good reference. Now, if I want to paint all of my drill holes by, let's say, copper %, I can just check the checkbox here for copper %, and there we go. So everything else is the same as before. You have your data cost, your statistics, your histogram, all of that hasn't changed. Now we can look at only one drill hole. So here I'm looking at drill hole 4Q15. It's highlighted here in 3D. And we can look at its kind of general information. So that is a drill hole, this color location. There was no dip and azimuth specified in that color file. So this is blank. There's its total length and the hole location, and you can see the deviation survey. So if I open this up, I can see this table, got my depth down hole, dip and azimuth, elevation, lift, and swing. I can't edit this at this moment, but if I were to change the drill hole status to like ongoing, then I would be able to edit as I'm drilling. I also have some metadata, so I didn't talk about it, but in that caller file, I have things like date logged and logger, and it could also be priority or drill hole type or any of that information that usually comes in your caller file. Apparently, I've been very busy logging day in and out, but in this fictitious info. And the idea is that all that info that you have in your caller file is being kept here as metadata. And then we can look at the assays, and we can, let's say we want to paint by copper %, we can click on that paint bucket. If you ever want to paint only one drill hole, you can always right click on that paint bucket and paint on 4Q15. And so here now we have these same tables as we had in the objects panel. I have my assays, geophysics, and that static survey. Now, one more thing about these new drill hole ASCII imports is that you can add more logs once your drill holes are already imported. Let's say you finally got that geology log from the team, or you've got some updates to include. Now you can go to File, Import, ASCII, Drill Holes. And now we're going to update the existing drill hole group. And you can update its geometry as well. But in this case, we're just going to add another interval log file. And we're going to add a geology log. We'll click OK. Again, we need to specify its columns. That looks fine. We'll click OK. You can click on that geology table and paint all my drill holes by my geology. There we go. And that's really it for the ASCII drill hole import and this new way that the drill holes are structured in our workspace. So now I'll move on to the next step, which is going to be the ODBC importer. So we now have two new importers in Geoscience Analyst, and one is to the acquired gene suite, and then the other is to the ODBC. And this is the one that I'm going to be focusing on today. So the first step for the ODBC connection is to create an INI file. It's a configuration file that you can open up in Notepad. It's a text file, so you can open it up in many places. And we need to start with a connection string so that Geoscience Analyst knows how to connect to that database. And I recommend going to this website, connectionstrings.com, to check out what your connection string should look like. In this case, I'm dealing with an ASCII ACCDB ODBC driver. So this is the kind of template that I'm working off of. And then all I have to do is edit it to point to the right location on my computer where that database is. And just to note that you need 2 backslashes there in between in your file path. And then the rest of the file is just pointing to the right headers in the right tables in your database. So let's say here I can colors. For the color, we need a table, whole ID, X, Y, and Z, and length. So my table is colors, whole ID is my whole ID column, and so on and so forth. And then we do the same thing for the deviation and the same thing for our drill hole logs or properties. Now, one important thing here is to make sure that this word in quotations is exactly what it's like in your database. And that includes capital letters, special characters, spaces, all sorts of stuff. So that's very important. And then once you have your INI file, you can save it with the INI file extension. And then we're ready to go to File and Preferences. And here we're going to specify where you have that INI file in your computer. So in ODBC settings, we're going to just go to the right place in your computer where you have those INI files. And that's it for that. Now we get into the actual importer. So I'll go to File, Import, ODBC, drill holes. And now we can choose our INI file. Mine was called Flin-Flon Axis, so I'll just choose that. It's giving us a little preview of our connection strings for reference. In the import, we can put we can specify a prefix for our drill holes that we're importing. Let's say we can call them demo. And I can also specify the name of the drill hole group. So I'll also call it demo. I can update drill holes that are already in my workspace. In this case, we're just going to import a copy. And we can specify properties that we want to import. Let's say for my geochem table in my database, I had by default specified silver and copper, but I can choose to include all of them if I want, or just some others like that. Then I can also apply some filters. So I can filter my drill holes according to its color location. And for that, I'm actually just going to draw a curve that's kind of like an area of interest. So I'm going to use O and left click to start digitizing a curve. Just around here. And then I'm going to close it using K and left click, escape, and I'll call it AOI, my area of interest. Those shortcuts for digitizing, they're all in the controls panel. So you have them there for reference for later. So let's say I only want to import the drill holes whose colors are inside this area. I can select this curve here. And now it's telling me that it's only going to import 36 drill holes out of the 121 that I have in my database. I can apply even more filters. For example, here I'm filtering according to the whole ID in my colors table. And I can say, okay, import only the drill holes that have the number 1 in their name, in their whole ID, for example. So you'll see all of these have number 1. I can do the same thing and say, import only the ones with the letter W. So in this case, only the wedges. Or I can also use regular expressions to do some more advanced filtering. For example, here I'm just copying a regular expression I had written elsewhere. And what this is going to do is that it's going to import all of the drill holes that do not have the letter W in them. So for this specific example, all the drill holes that are not wedges. And combining these 2 filters, I'm going to be importing 27 drill holes. Great, so I will click OK. Great, I'm just gonna go in there. Parallel view is easier to get a good look on whether those colors are in your area of interest or not. So I just went on to this view right here. Yeah, so you'll see we only imported drill holes inside that area, and they only have those logs that I specified. So I had specified these 4, for example. And there's no wedges. There should be no drill holes here with the letter W in them. And yeah, so other than that, the visualization's all the same as our drill holes before. Okay, so I believe with that we are ready for our last subject of today's lecture, and that's going to be georeferencing images. And just to give you an idea of what data I have to start with, I have this geology map and cross-section from the Geological Survey of Canada. I believe it's open file 3872. And this is from the area just southeast of Montreal. The Montreal Islands right around here. It's like a 1 to 2 hour drive from the city. So I was out there a couple of weeks ago, just hanging about. And so what we've got is a bunch of sedimentary rocks. And then you'll see these little blobs. There are some plutons with some hornfels rings around them. So that's the kind of environment we're hanging out there. It's called the Montérégie Hills. And I want to get this into my workspace. So what I've done is that I've taken just screenshots of the maps and the cross section. And I have something that looks like this. And with that, I'm ready to import. So I am just gonna come over here to where that geology map is. It's the PNG, and it is going to be importing at, let's say, 0 elevation. And it's also importing at 0, 0, 0 in XYZ. So this has no location information whatsoever. It's just a PNG. So it's kind of importing in the middle of space here. But what I'm going to be doing is that I'm going to be using these shape files that I also found in the Geological Survey of Canada website. And so I'm going to be using these lakes and these rivers to georeference that geology map in its proper location. And I also have a topography surface from that area that we're going to be using in a second. Okay, so now just set this up properly. I am going to add another viewport. And then I'm going to move it around and put it next to it. And then in this one, I'm going to show my geology map. And then in this one, I will show my shapefiles with the lakes and rivers. There we go. And now we should be ready to georeference. So I'm going to right click on the image, georeference to landmarks. And then I'm going to choose my reference object. So that's these lakes that I'm going to be using here. And then I have to choose the point in an image and then the corresponding point in our shapefile. And it's the usual notes that it's good that they're always spread out, and you need at least 3 of them, but you can add more if you want. So I'm just gonna do this as quickly as possible, just so I don't bore you here. So if I haven't already. Okay, so there's my geoimage point. Then I'll go in and specify my shapefile point. Now I'm also going to try to use this link and see what happens. I'll admit I haven't used it before, but I'm going to give it a shot. So I'm going to pick this point, and then same point over here. Great. We are almost there. Just bear with me. I'm going to choose another one over here. And I'm doing this really quickly, so it might not be the best georeferencing ever. I know that when I do it carefully, I get an awesome result. But if I'm trying to be quick like this, I'm definitely going to be off. So don't judge my georeferencing skills. Well, we'll look at the error. It'll probably be pretty bad. Or at least it was when I tried to go really faster in practice. Okay, I'll click apply. Now that we have those 3 points, and I like to use apply instead of okay, just so that it keeps this window open in case I need to edit this a little bit without having to redo it from scratch. And it created a copy of my geo image, and now we can go in here and I'll make it a little transparent and I'll see how well did I georeference this. Actually, it wasn't too bad. Better than before. Okay, I will pat myself on the back there. Can always use a tape measure, that's T and left click, to see like how off you were. But in this case, for this exercise, I'm not going to worry about it too much. But yeah, so now we have it in the right location. We matched it up with our rivers and our lakes. Now we also can paint that on our topography surface. So let's say here I'm showing my topography. I can paint my geo image, which was the registered one right there. And it doesn't look like anything happened, but there is some relief there. You can always turn on the vertical exaggeration. And then you can see that indeed this is being painted on the topography. And so yeah, you see those flutes and stand out pretty nicely. I'll bring this back to 1. All right. Now, almost done. The next thing will take just a couple minutes. So what I'm going to do is that I am going to do the same exercise for my cross section, which again, it's a PNG that's importing flat. It's importing horizontal and it's importing at 0, 0, 0. So this has no location information whatsoever. And I'll just reset this back to where it was before. Here we go. So what we're going to do is that we're going to be using this A to A prime and then this A to A prime in the map to put our cross section in the right location. So let's right click on that image, georeference to landmarks, and then we can set the geo image point. So I'm just going to zoom in a little bit. Again, I'll be as quick as possible. A here corresponds to that A there. And then I'm going to do this one at depth at 4 kilometers. And then for this one, I'm going to put the same X and Y as my initial A, but then I'll put a Z of minus 4,000. Then I'll do my A prime right here. A prime left, just right around here. and I should be ready to go. I can click apply. I'm going to hide this other viewport, and now I should be able to see that cross-section properly georeferenced in space. It looks like it did an all right job, a little bit off in some spots, but that's not too bad. And that's it, really. That was ASCII drill hole imports, the new drill hole structure, ODBC imports, and georeferencing your images. And that's all I have ready for today. Know there's any questions?
Sorry, I just had to find my unmute, Carla. Yes, we've got a couple of questions from the drill hole section. From Peter Ronning. He's just asking if the log in the console can be saved to file. I believe I can also answer these if you wish, but there we go. So Carla is showing you that that console is being saved every time you use Geoscience Analyst into a log file in your user's Geoscience Analyst logs. And also you can highlight and copy paste from the actual console itself.
Right.
Oh, we got a third question come in as well. So Subhash Bastola, I hope I've pronounced your name correctly, Subhash. I have a lot of drill holes, around 12,000, and I want to filter only the ones that intersect a geological structure, like a fault or a dike. Is there a function to do that?
I don't think so.
Sorry for everybody. I'm the sort of product manager for Geoscience Analyst, so I can also answer some of these. We don't really have a way to do that at the moment once the drill holes are in, but I think Carla is going to the same idea that I am, is that if you are importing from a database, you could use your filters and filter off of your geology table, perhaps, or a structural table if you're importing structures for a specific unit or contact or anything like that. And the nice thing about the drill hole groups now in Geoscience Analyst is that you can actually have, you can actually create different groups of drill holes to do that kind of filtering. But we are aware that these types of filters are desirable. So I would say watch this space, but I can't tell you sort of when that functionality might come in. But we recognize that type of thing is key. And then our last question I have from Yuhang Zhu. Can you show us how to load and view seismic data, please?
Sure.
Spot, Carla.
So we support the 2D SegWi and the 3D SegWi. I'm just gonna load a 2D SegWi really quickly here. So basically just drag and drop it in. It should recognize whether it's 3D or 2D. Usually this you can leave by default. It's just the line and trace byte locations and location byte locations. Whether it's depth, elevation, or time. And if it is in time, you can specify a constant velocity function to transform that, to convert that into elevation. And you click OK, and it will take a couple seconds. So it'll pop up soon. There we go. Question is, where did it pop up? Oh, it's there somewhere. So it should load like that, and we should be able to visualize. So there we go. It's being a little funky. But yeah, you should be able to visualize your seismic data. You can choose the right color map and the right what's it called, color mapping function. So let's say here I can choose flag. And so that's the way that you would visualize your seismic data. There's also now this area clipping, which is really cool. And I don't think I'm going to demo right now because it does take a second. Apparently I will. So it's you can choose which area of that seismic line you want to show. So that's one way of going about it. It's kind of a similar process for your 3D SegWi. Anything you think I should add, Jennifer?
No, I think that's all really good. Anyway, thank you, Carla, for doing the presentation today, and thanks for everyone who joined us. If there are any more questions, I will give you another 30 seconds or so to type your questions into the chat. And if you have any questions in the future, please don't hesitate to email us at support@mirrorgeoscience.com. Carla is the one who takes care of our support, so she'll be the one getting back to you. And also join us next month when Christopher Davis will be showing us all how to invert time domain data using VPEM1D in Geoscience Analyst Pro Geophysics 4.0.
All right.
No more questions. All right. I think that's all. Thanks again, everyone. And we'll see you next month.
Yep. Thank you. Bye.
Bye.